Okay. Sweet. How's everyone doing today? Pretty good? Happy Wednesday. Good, good. So, hey Dimitri. So today we're going to be talking about resources, which is I'd say probably like the first major topic of Cadence that we're going to cover. Arguably the most important topic we're going to cover. And what makes, Cadence this resource-oriented language that we've been discussing over the past couple workshops. Um, what we're going to learn today, resources, again, it's what makes it like the resource oriented thing. It's also similar if you've coded in like Move. So if you've come from Aptos or what's that other blockchain called? Like Sui, I think it's called. They use like Move as well. And Move uses this like resource approach as well. So if you've coded in those languages before, you will also find this quite similar. So what I'm going to do is I'm going to go ahead and make a contract. I'm also going to increase the font. Um, Hello world. All right, and what you've seen so far is basic types. Like we saw a string. You also saw structs, right? We covered structs, and this is probably the most important. Let's say we have a struct called profile. And this struct, let's say it had a ID. It also had like I don't know, a name, right? And then what we had to do was we had to initialize these variables. We could pass in the ID and the name, which is a string, and then we said something like, self.id equals ID, and self.name equals name. All right, I'll get rid of the greeting for now. And then let's say we wanted to create one, and this is all review, by the way, so I'm just reviewing what we went over in the last workshop. Let's say we wanted to create a struct. We could have a function called like create profile, where you take in an ID and a name, and you say let profile, or actually, yeah, it was let profile equals a profile where the ID is ID, the name is name, and then we could, I don't know, like log, or we could like return this profile, or we could do whatever we want with it. Um, there's infinite number of things we could do with it, but this was like the basic. How do you like define a struct, and then how do you create a struct? And in this case, we're just calling it profile. So this was the review of last time. Now, the reason I typed this out is because resources are actually very, very, very similar to structs and how they're defined. They can have variables. They have to have an init function to initialize those variables, and they can also have functions. So if we have a function called like get name, we could have a function in a struct, all this cool stuff, right? So resources are very similar, and we're going to discuss the differences between resources and structs in a second here. So let's say we want to make a resource. Well, literally, all you have to do is change struct to resource, and now we have a resource. And you'll notice as soon as we do that, we actually get a lot of errors here, and this is where we're going to start to get into the differences between them. So resources are similar to structs in that you can have variables, functions, all that stuff, except that they're treated very differently in Cadence. They're treated much more securely, and they're treated as actual assets, um, or objects that you have to like move around, and that move keyword is very important. So first of all, let's actually look at our errors here, and we'll just walk through them. So line 18, or actually, which one do we want? Okay, let's look at this one first, or this one actually. So it says line 18 cannot create resource expected create. So the first difference between resources and structs is with structs, you can actually create them outside the contract. So if this was a struct, we could go into a oh, actually, sorry, I think it's a script, yeah, or a transaction, either one, transaction or a script, and we could just create that struct and pass it around. We could go in here, we could create the struct, return it, we could do whatever we want, right? The difference with resources is they can only be created inside the contract, and in order to create them, you have to actually put a create keyword, okay? So you'll notice we get rid of one error so far. But again, no, create can only be used inside the contract. So resources cannot be created in transactions or scripts. Um, we could make a function that creates it and returns it, and that's actually what we're doing here. And you'll see that once this is completed. So the next error is, let's look at this one. Line 18 says incorrect transfer operation expected, this little arrow. So let's try that. What the heck does that even mean? Let's try to change this equal sign to an arrow. Up, and we got rid of another error. So the arrow is what we have to use with resources. You cannot use the equal sign. You have to use this, move symbol to move resources around. And the reason for this is because you cannot copy resources. So unlike structs where you can create a struct, copy it, return it, set it equal to another variable, all that fun stuff, with resources, they can only exist in one location at a time. And when you think about it, like let's think about, NFTs, for example, as a resource. This makes perfect sense for assets, right? Because we don't want our NFTs to be able to be copied. We don't want them to be lost, right? We want them to be moved around, and it helps developers that they have to explicitly put move syntax when they want to move it around. So it's harder to lose, very valuable assets. Um, this is different in languages like Solidity, where a NFT is literally just represented as a number, and it's easy to accidentally overwrite that number or lose it, or etc. Whereas in Cadence, you have to be super explicit, so the security for developers is much better. Next problem, missing move operation. Again, we're returning the profile, but we're not explicitly moving it. We actually have to tell the language, okay, we're going to move the profile into the return value. And then the last error is it says missing resource annotation, and that's because the type of a resource is not just defined by the name that we give it. You also have to put this at symbol in front of it. So whenever you see, this symbol and then a name, this means this is a resource. All right. So, and again, remember I said we can only create profiles, or we can only create resources inside the contract. While that is true, in this case, we actually define a function that allows us to create it and then return it to the caller. So we can call this function inside a transaction or a script. It's just that we wouldn't be able to create resources directly using the create keyword. Pretty cool, right? So let's now go ahead and try to, let's just like play around with this profile. So I'm gonna change. Oh no, so this symbol literally just means it's a resource. So when you see something like this usually means it's a struct, because it's just like it's a name that we haven't heard of, and it doesn't have the at symbol. But when you have the at symbol, this means it's a resource. Yeah. So let's go ahead and change this function just to make things more interesting to like set name, and we're gonna pass in a new name, which is a string. Oh my god, which is a string, and we're not gonna return anything, and we're just gonna say self.name equals new name. We're gonna make this var because we're gonna change it. And actually, you know what? Let's change this to an NFT, because I think it'll be cool if we start thinking about this in the context of NFTs. So let's actually do that instead. NFT, create NFT. Cool. Sorry, a bit sick. Okay, so let's go ahead and deploy this. Where's the button to? Oh, here it is. So let's take this button, deploy it to account one. I think that worked. Boom, that worked. So we can now go to a transaction. We import hello world from account one. We just deployed it. And in the execute phase, we're going to say let NFT equals hello world. Oh, I think we can actually refresh the page and it'll hello world dot create NFT. And we can pass in an ID and a name, right? Actually, now this is interesting. So one thing I want to show you is that a cool thing about resources is they have a field here. You can't see it, but they have a field here called UUID. It actually looks exactly like this. And you'll notice that if I hover over this, it says, oh, well, I'll show you in a second here. If I do like self.uuid equals 1, look at this. So it says cannot declare field here, UUID. So the reason we can't declare this field here is because resources actually automatically have this field. You just can't see it. But it looks exactly like this under the hood. Um, so what I actually like to do is instead of having to pass in an ID for my NFTs, I actually always set them to self.uuid. And that way you don't have to pass in an ID. And what a UUID is it's a unique identifier across every single NFT on the entire chain. So no resource, even if it's destroyed, no resource will ever have the same UUID as any other resource in existence. So I think it's actually really helpful because the whole point of IDs, especially, I guess like with other types of resources, like let's say it's like a profile and you want to have an ID, you could do like a incremental ID, like 0, 1, 2, and track some sort of total supply to have that increment. But at least with NFTs, the concept is that, the idea of an NFT is unique. That's what makes it an NFT is that it's unique and its ID, right? So I always use self.uuid for, something like this if I want to represent an ID. And when we talk about the NFT standard more, you'll know why I'm sort of like taking so long to talk about this. But I guess we can just delete the ID field for now. Okay. Let's go ahead and redeploy that. Let's go to a transaction. And if we refresh the page here, it should say, okay, we don't need the ID anymore. So let's go ahead and pass in the name. Now we have a transaction argument, but we get an error here, and you should all know how to fix this error. What is the problem with this right now? Why am I getting this error? Exactly, Darth. So again, with resources, we have to move them. We can't just say equals. So we move it into the NFT, and then we encounter this other error, which we haven't really seen before, which is loss of resource. So why is it saying that? Well, the reason is because in Cadence, you cannot leave resources. I just call them like dangling. You can't leave them alone. So we have to actually put the resource somewhere. And the answer is we can either one, destroy it, or two, move it somewhere else. Okay. And somewhere else usually is two options. It's either into a user's account storage or two into a contract storage. In this case, because we're not going to do either, we're simply just going to destroy it, which uses the destroy keyword. So we say destroy NFT, and that destroys it. Okay. Now we don't have the error anymore. So what we can do is we can log nft.name. We can this will just print the name to the console. Then next we can say nft.set name. We can change it to a new name, which is just like say Bob, and then we can log nft.name again. And let's see what happens when we run this. So for the name, I'm gonna type in Darth because Darth answered the question. I'm gonna send this, and you'll see in the log we get Darth, which printed right here, and then we changed the name to Bob and logged it again, and we get Bob, and then we destroyed it. So this is, a very, very, very simple example of resources. All right. How we doing? I'm gonna put a little thumbs up in chat if this makes sense. Thumbs that up. If you're having some trouble, thumbs that down. No shame in either. Okay. So the next part of this lesson, I believe that was actually all of chapter 3, lesson 1, I think. Next we're going to talk about, let me just make sure. Yeah. Okay, so next we're going to talk about resources in dictionaries and arrays, and this is fun. Also, by the way, you'll notice that I don't know if any of you have seen this yet, but we actually embedded the YouTube videos directly into the content now instead of having you click on links. So hopefully it's nicer for all of you to be able to directly watch the YouTube videos. And on top of that, the quizzes, instead of just being like a random link at the bottom, the quiz is actually a link on the sidebar here, so you can pull up the quiz directly. And also you can jump to the video lesson, you can jump to the quests, whatever you want. So hopefully the UX is a lot better. And also we included an author here, so that like you can actually make your own courses and list yourself as the author. And we have someone in the academy right now that's launching their own, I think, like dancing course where they're teaching people how to upload or teaching you how to like record dance content on the blockchain or something like that. You'll see. Um, so yeah, thanks, Dimitri. Okay, so let's talk about dictionaries and arrays now. And the reason we're going to talk about this is because we want to start getting into, instead of just destroying the NFT, where can we put it, right? Where is some place we can store it? Well, the answer, an easy answer, is in the contract. So let's make a list of, let's just say list of NFTs. And what we're going to do is we're going to map the ID of the NFT to the NFT itself. Okay, cool. So, oh, we get a problem. It says, I'll read it for you. It says missing initializer of field list of NFTs. The reason for that is because, well, we don't initialize it, right? We don't initialize it. So, oh, you know what? I just had a random idea, Dimitri. I think, what would be so cool is if we slowly made like a glossary of every single error message and just like put a solution for it. That way people could look up the error and then like maybe it's a lot of errors, but I don't know. I think that'd be helpful because some of the errors are like very common, or just like on Emerald Academy or somewhere. Because the reason I say that is because a lot of errors in Cadence are super common, like missing initializer, loss of resource, whatever. Or even like Raven's right, like even in the playground UI, we could have like a glossary where a user could open up a page and they could paste in this error and it will just show you like what that means in plain English. I think that'd be super helpful. That would be like pretty revolutionary, right? Because I haven't seen that in like Solidity or anything, like a direct mapping of error to solution. And I'm not even saying it has to like suggest code. I'm just saying like it could literally just like type, like it could just say in English or whatever language, like like missing initializer usually means that you need to add an default initial field, value in an init function or something like that. Of course, like it'd be cool if it like auto suggested solutions, but I think that's probably complicated. Okay, anyways, back to the lesson. So we have to initialize this field. So what we have to do is say self.list of NFTs equals an empty dictionary. But there's multiple problems here. Number one, this is a dictionary that contains a resource. And so you would think that we have to put the @ symbol in front of the type because this is how you represent the NFT type. But it's actually a bit weird with dictionaries and arrays because instead of putting the @ symbol here, you actually put it in front. So you put it over here. So this signifies that this is a dictionary that holds resources inside of it, right? Cool. So then we can go into the init function here and add an arrow, right? Because we can no longer just say equals, we have to add an arrow here because we're dealing with resources. Okay, cool. Yeah, exactly, Dimitri. I feel like it'd be pretty. I feel like I should just put this on Emerald Academy somewhere, or just like have like a long glossary because it's super easy to implement. It's just like, oh, here's a search bar, put the error, and then it'll take you to the solution. Yeah, I think it'd be sick. Okay. I don't know where we would put it. I guess Raven, do you have any suggestions? You're my consultant here. Where should we put this in the like where I don't know. Okay, sorry, I'm getting distracted. So instead of creating, oh yeah, so what have a function for creating NFT? Oh, you mean like resources? I mean this page is we're gonna revamp this page big time just because like it's not that useful, but yeah. Um Yeah. Okay, so anyways, so yeah, so we have this function called create NFT, then we're also going to make a function called store NFT, okay? And what this is going to do is actually pass in the NFT resource and then store it inside the dictionary. So what I'm going to do is I'm actually going to take this function up top. That way we can see both the dictionary and the function at the same time. All right, so the way you do this is that there's actually two ways to insert a resource into a dictionary. I'll show you both. The first way is to say self.list of NFTs dot insert. The key is the NFT.id, and the value is the NFT, right? Oh, actually, is this even possible? Oh no, I'm sorry. You can't do that with resources. Um, okay, my bad. There is two ways, but it's not that one. The first way, remember, is you can't overwrite resources in Cadence. Cadence doesn't let you overwrite resources because it treats resources as valuable, right? So you can't do that. So it's actually tricky because remember the way the dictionary works is you're mapping a key to a value, but the dictionaries or Cadence rather doesn't know that IDs are unique. So in Cadence's mind, it's possible for us to, for like let's say an NFT with ID 1 to exist and then another NFT to come along with ID 1 and accidentally overwrite that if we go to insert again. So this is where we have this problem. So let me show you two ways. The first way is you say self.list of NFTs at NFT.id and then you move in the NFT. The only difference is you have to add this force symbol right here. And what this symbol does, this is my favorite symbol in Cadence. I love it. It seems like super complicated, but it just looks cool. This symbol means we're going to move the NFT into the dictionary at this key. If a value already exists at that key, panic and abort the program. Okay, so that's helpful because that means we can't overwrite the resource. Or if this key doesn't exist, then insert it. Okay, so that's what this means, and this is how I always insert into dictionaries because I just think it's the best way to do it. I never want to overwrite NFTs, or not even NFTs, but any resource. I don't want to overwrite them. However, the second way to do this is to say let old NFT and just stick with me here. Self.list of NFTs NFT.id NFT, and then to destroy old NFT. So this is another way to do it. Now, in my opinion, this is a lot more complicated, but it serves sort of a different purpose. Where what this does is this removes whatever is at that key and then moves in your NFT. And then because remember I said we can't lose resources, we just destroy it. So what this is basically saying is if there already exists a value there, then move it out first and then move our thing in. And then we can destroy it, or instead of doing this, we can do something with the old value. All right. So let's say in some sort of use case, there are a lot of NFTs with multiple IDs, or let's say it's a different example with profiles, and profiles have the same IDs or something like that. You can move out the old one and then do something with it. But for this purpose, I think this is a lot easier. Okay. We can also make one called that says remove NFT. We take in the ID and we return the NFT resource. And the way you can do this is you can say let NFT self.list of NFTs.remove at the key, and then return NFT. The only issue here is it's saying, wait a minute, we expected a Hello World NFT, but we got a Hello World NFT optional. The reason it's saying this is because remember, when you remove from a dictionary, you're actually getting an optional type. So we can fix this either by just putting a force unwrap and saying, wait a minute, if this key or if this NFT ID doesn't exist, just abort the program. Or we can put panic and say, sorry, this NFT does not exist. And I always think panics are better practice than just force unwrapping because it's more clear for the user who runs into the error. Okay, so now that we know this, let's go ahead and deploy it. And let's go back to our transaction and just do some fancy stuff. So what we can do here is say we can create the NFT, right? We can log the name just for fun. Then we can go ahead and say hello world dot. Let's refresh the page so we get the syntax highlighting or suggestions. Dot store NFT, and we're going to remove our NFT in. Okay, and then we're going to log done. Oh, one last thing I want to do also is I want to add a function called get IDs, and this gets a list of UN64s where we return self.list of NFTs.keys. So we can read all the IDs of the NFTs that live in this dictionary. Okay, let's deploy this. All right, this is our transaction. Boom. So our name should be, let's say Raven. We can send this. And in our log, we see we get Raven, which was the name. We created it. We logged the name, which was Raven. Then we stored it and we logged done. Done, right? Cool. So technically, I guess this NFT should be inside our list now. So we can check that. Let's import hello world from 0x01. Let's return an array of UN64s, and let's say return hello world dot get IDs. All right, and if we execute this, we get this, small, like I don't know if you can read it, but it's an array of values, and it's 38. So the ID of that NFT is 38. Pretty cool. So we know that it's inside the contract. Now let's add another transaction. Let's call this one, I don't know, like store. And let's call this one remove. So inside remove, let us remove it. So we can go here and let's say let NFT hello world dot remove NFT, and needs an ID. So we can actually pass in the ID up here, and then we can I don't know, destroy it. All right. So we know from our script, we know that the NFT's ID is 38. So let's go ahead and type that in here, 38. Send it. We get done. So if we go to read our IDs again, we get an empty array. Right? We get an empty array because we took the NFT out and destroyed it. So how's everyone doing? I'm going to put a little thumbs up. If you're doing good, thumbs that up. If you're doing bad, thumbs that down. I believe that is what I wanted to cover in this lesson as well.
Can't innovate anymore, my ass.
Raven, what was that? Oh my god. Yeah, of course. Let me do that. Share copy. I think it's just this one. Does that work? Okay, yeah. Um, cool. And also, just to show you really quick before we go into the last lesson, let me show you how to do this with arrays, because arrays is also, anything with resources is pretty complicated. So let me also just show you arrays real quick. So we're gonna do an array of NFTs instead. So store NFT, the way you do this is you say self dot list of NFTs dot append, I think. Actually, yeah, I think it's just that. How do I do it in the lesson, actually? I want to make sure I'm following what I do here. Da, 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 da. Okay, how do I do this? Oh yeah, okay, so it's just append. Okay, got that right. So yeah, like any other thing, you just use append. The only difference is that you have to use the arrow because you're moving it into the array. And if you want to remove NFT, oh, the function's already here. I'm an idiot. Sorry. Then you just do let NFT self.list of NFTs dot remove. The only difference here is that because it's not a dictionary anymore, you don't pass in the NFT's ID, you actually pass in the index. So you pass in the index of, remember, it's like 0, 1, 2, 3, and it goes on for the list of, the length of the array, -1. You have to pass in the index. And then we can return NFT, right? So, yeah. And then if we want to get the IDs, it's actually a lot more complicated, I think, because for get IDs, we have to loop over. I guess we wouldn't really need this, but we'd have to loop over the whole array and keep track of the IDs. But yeah, so this is just for arrays. Yeah, no worries, Dimitri. Actually, Um, that is super true, and that's actually the entire reason why quests exist. So at the bottom of every single lesson, there's quests, and that's exactly what you're saying. It's like there's simple exercises to help you learn. And from my experience, like you're never gonna really learn anything unless you do the quests. Um, I just think they're like by far the most helpful. And you'll see like on some days, like for example on chapter 3 day 1, like the quests are there's a lot of them and they're all like pretty simple, but they're definitely necessary to actually like make things work. And also on top of that there's a quiz, but the quizzes are more like theoretical. Like you'll see here like, for example, when mapping a dictionary to a resource, where is the at placed? Right? What's the answer? Anyone know? I actually have not read these over a lot. Um is it A, B, C, or D? Let's pretend like we're in high school, and I'm the super awesome teacher. And if you get this wrong, you get detention slash banned from this Discord. No, incorrect, Dimitri. Incorrect. Yes, correct. Correct, Darth. Yeah, it's this one. And look, it is because remember the example we covered today? Let me bring it back. See? It's right here. It's in front of the type. Boom. So B. Let's actually fun. Let's keep going. What is used to differentiate? Oh my God, Raven! If you make one more noise, I swear I'm muting you. Where? Let's see. What else is fun? Oh, what does the this? What does the exclamation mark do in line 7? Let me. I actually don't even know. Let's read this. A. It panics if nothing has been mapped already. B. It forces the resource to be mapped no matter what. C, it panics if something already exists. D, force unwraps. All right, what's the answer? Is it A, B, C, or D? I know the answer. Come on, class. Yes, Dimitri. Good job. It's C. Good job. Good job. Woohoo! Um. Okay, let's see this one. One more. Oh, create can only be called inside the contract. True or false? Oh God. Oh God. Dimitri, are you serious? I covered this one today. Yeah, so this is actually right here. So remember, the create keyword can only be used inside the contract, not in transactions or scripts. All right, one more. This is fun. Um. Oh, well, I think that's actually it for today. Oh wait, that's it for this one. Well, yes. The thing is, you can call this function because it's almost we made like a wrapper, but this keyword can only be called inside the contract. But this is like a wrapper we made to call it anywhere. Yeah. Okay, let's try. Let's go back to here. All right, let's try the quiz for chapter 3, day 1. Um, let's see. Okay. These are pretty easy. All right, let's try this one. When destroying a resource, actually, let's try this one. What does this error message suggest? Loss of resource. Yeah, Dimitri's not allowed to answer this one because we have to let other people embarrass themselves. What does this error message suggest? Loss of resource. Anyone? Either Falcon, Powell, or Generous Kid. Any ideas? Yeah, but you're not allowed to answer this one yet. You can't answer this one. Let's see if Falcon can get it. Falcon's actually a graduate, so I think Falcon should get this one. Some of these are funny. Yeah, exactly. It's this one. So your resource has now been moved or destroyed. The person who actually made this was Frankincense. I'm actually gonna ping. Frankincense. But Frankincense is the one that made these quizzes. So he actually went through the whole course and then like made the quizzes as he went along to help himself. So they're super helpful. But yeah. So there's these quizzes which I think are really fun. And there's the quests are I made these, and these are I think are like these are like really directly related to this. Not that the quizzes aren't, but these are like if you get the quizzes, or if you get the quest right, then I think you're good to go. Um, okay. Back to the course. What did I else? Oh yeah, I think we wanted to cover references. Okay, so references. Um, cool. So yeah, we're at references now. Um, So the reason I want to cover references and the reason they're really needed at all is because um, when we want to read information about our stored resources, we need right now it's really annoying, right? If we were inside of a script, how would we right now? How would we read the information about one of these NFTs? Like, how would we get to the name of one of the NFTs right now in the script? Any ideas? Like, if I wanted to run a script to read the name of one of the NFTs in this dictionary. How would I do that right now using these functions? Yeah, so yeah, that's definitely exactly yeah. So the IDs are mapped. So the way you do it right now is you would read the IDs and you would say, okay, these are the IDs that exist. Then you would take one, you would remove it, right? You would remove the NFT and you would have it over here. You would log the name and then you would, call the store NFT to return it back, right? Now, this is extremely annoying. In order to read the data of an NFT right now, we'd have to remove it, read it, and store it. And that's just like super annoying. There's no reason to do that. And this is where references come in. So references, get NFT reference, is a way to, basically obtain um, obtain information about something without actually having to move it. And this is references are most often used with resources because of this reason. So we can take in the ID of the NFT and return the reference to the NFT. So you'll notice that a reference is denoted using this symbol, the or what is this called? Ampersand, I think. It's denoted with the ampersand symbol. So cool. And this is where stuff gets a little complicated because now we're going to deal with trying to read a dictionary, which returns an optional, but we're then going to try and get the reference of the optional. So this might get confusing, but just stick with me. If the resource is private, can you reference it? I'm trying to think of what you mean by that. If the resource is private, I think you mean like no. It's a good question. I think we're gonna get to that later. Uh, I mean, there's ways to like hide this, but we haven't really talked about access control yet. But we will get there. Don't worry. Okay. And you're right, Dimitri, because like for example, let's say right now this gives a reference to the NFT, which you'll see will allow us to call things like set name. And what if you wanted to allow someone to read the name of your NFT, but you didn't want them to call the set name because then, I don't want someone changing the name of my NFT. We will talk about ways to allow some things and not allow others, and that's more in like access control and resource interfaces, but that's all next week. Okay. So let's get a reference to the NFT. So let's say let NFT ref equals a reference to self.list of NFTs at the ID as a reference to actually, is there a way to do this so I can show you the errors? What's the error right now? Oh yeah, okay. So you would think it's something like this, right? Where you get a reference to self.list of NFTs at ID. However, with references, you always get this error, which is expected casting expression. What this means is you have to cast. It's called this type to this value to a type. So we have to say as a reference to an NFT. Okay. This means that we're getting a reference to this thing, and we're expecting it to be a reference to an NFT. Now we get this error, which it says mismatched types expected hello world.nft got hello world.nft optional. The reason for this is because this was actually an update to Cadence that happened during Secure Cadence or Stable Cadence, I believe it was called. I don't remember which one. But the update that happened like a year ago, where they introduced optional dictionary references. So what actually gets returned is an optional. And I actually loved this update because it makes a lot more sense with what dictionaries do usually, which is remember when you index into a dictionary, you get an optional type. So the only difference here is that we're just getting an optional reference type because we're just getting a reference to it. Okay. And now you'll notice we get another error, which is on line 7. We're getting the same error. The reason is because if we just change our return value to an optional, it'll work totally fine. Because remember, we have an optional type. It's just that we were returning a non-optional type. But I think it's always better to return the optional type here because when we call into this function with a certain ID, if the NFT exists in that dictionary, we will get the NFT reference. If it doesn't exist, we'll get an optional or we'll get like nil. So it allows the caller to better handle the situation where it does or doesn't exist. Whereas if we were to return a non-optional type like this one, right? Then if someone calls into this function and it doesn't exist, it's just going to panic and abort the whole program, which, isn't that helpful because, what if they want to handle the case where it doesn't exist, right? So um, this is better, okay? So let's deploy this. I deployed. And we can go to our transaction now, and let's just call this change name, okay? So if we copy this transaction, go here, what we can do is say let NFT reference equals hello world dot, oh, let me refresh the page, dot change. Oh, I think it's called get NFT reference. Boom. So this returns a NFT reference. And then we can do stuff like log NFT ref dot name. Oh, remember, we're getting back a reference to a hello world dot NFT optional type. So what we can do is here, remember, we can handle the case now where it doesn't exist. We can make this a full NFT and just say panic if it was a nil. Sorry, there was no NFT there. Okay. We can log the name and then log done. So let's go ahead. What's the error here? I feel like it's just being weird. Oh, okay. Um, oh, we don't even know the ID yet because we haven't stored anything. So let's create an NFT, call it Dimitri, send it. Okay, we stored it. Let's call it a script. We know the NFT has an ID of 39. So let's go ahead and call this transaction. All it's doing right now is it's getting a reference to it and logging the name, which is Dimitri, right? And the cool thing about this is, remember, is that we didn't have to remove the NFT, read it, and store it back. We simply were able to just, get a reference to it. So now let's actually do NFT ref dot set name. We'll set the new name to Alice, and then we'll log the name again. Boom, right? So if we call this one, we get also, Dimitri, one piece of feedback also is that the this is a little confusing how they like log the outputs. I think on the old playground it logged it where like the latest ones would just go downwards, meaning like this was the least recent, this was the most recent, and it got more recent. When it's reversed order, it sort of bugs out, and I think it also is just not logging it right. But anyways, if that's helpful. Um, but essentially, what it did was it logged Dimitri here, Then it changed the name to Alice, and then it logged Alice here. Okay. And the cool part is that because this was a reference, right? Even though we didn't actually remove the resource from the storage, from the contracts, dictionary, we actually still did change the name, which is really cool. And you'll notice that if we were to run this again, right? If we were to run this again, hopefully the logs go away so I can show you. With 39, it actually was permanently changed to Alice, because we changed the name. Is that making sense to everybody? Claps, claps, claps. Woohoo! Thanks, Raven, for the support. Perfect. All right, so. Oh my god. Oh my. All right, that is references. I love it. I love it. I think that's everything I wanted to cover. So that's references for you. Um, yeah. Any questions? Sure. Although I should probably change it with the. I should probably add the set name because this transaction is called change name. We actually pass in the new name here. I make this the new name. It's probably better. All right, we can share this. Boom. Cool. So that's the end of today's workshop. I hope you enjoyed it. And with that being said, I will see you all on Friday. When we see each other next, it'll be Happy Friday. Oh yeah, let's save this, right? Let's call this I can change the name here. Um, Chapter 3, we'll call it. Nice. Cool. All right. Enjoy Wednesday, everybody. Bye now. Thanks, Generous Kid. Bye, pal. Bye, Falcon. Thanks, Raven, for all the sound effects.